Okay, so we got to question 5, which is saying find the future value of an annuity, same payments paid over the same time interval. Example can be your salary. Salary is a fixed payment and it's paid every time after a month. Even when you pay rent at where you're staying, you're paying your landlord the same amount after a month. Right? Even when you are paying out interest for a loan, you be paying the same interest amount over a certain period of time. So find the future value of an annuity for 2,500 paid at the end of each year for 3 years, assuming interest is compounded annually at 26%. That is the first part of the question. Right. So here, since the question said this annuity is paid at the end of each year, so it's an ordinary annuity. Okay, and as like your salary, you are paid at the end of the month. Okay, so that's an ordinary annuity. So this is the formula to get the future value of an ordinary annuity. So it's compounded annually, so n equals 1. So remember this n, you're just supposed to divide it with the rate and multiply it by the time. But since it's 1, so it's not going to affect anything. Okay. But if it was compounded semi-annually, we would know this. If it's semi-annually, it means n equals 2. So this interest rate, we divide it by 2. This time period here, we multiply it by 2. And this interest rate would have also divided by 2. Okay, so in this formula, FV is the future value. Okay, the amount in the future. This A represents the same payment, the fixed payment. Okay, so in this question here, they said it's 2,500. Okay, at the end of each year, you get 2,500. So the A represents the equal payment, which is paid periodically after the same time interval. R just represents the rate. T is the time period. Yes. So for this question here, we find the future value. I'm going to say 2,500. We make so that it's visible here. Yes, 2,500 multiplied by open brackets 1 plus R. So 26% in decimal is 0.26 to the power T, not to the power T minus 1. Okay, let me even put it properly here on the formula. To the power T, so that's 3 years. The power 3 minus 1 divided, all of this divided by 0.26. Okay, that's how the formula is. A, open brackets, multiplied by 1 plus R to the power T minus 1, close brackets, divided by R. So all of this is divided by R. Okay, this whole tabulation here is divided by R. Let's get our calculators. So say 2,500 multiplied by, so 1.26 to the power 3. So this 1.26 to the power 3, after we get it, we have to subtract. Immediately after you do this tabulation, 1.26 to the power 3, subtract it from 1, okay, before you will multiply. So 1.263 to the power, 1.26 to the power 3, what do we get? 1.26 to the power 3, 2.00. So just write it as 2 minus 1. All of this divided by 0.26. 2 minus 1 is 1. 1 times 2,500, you get 2,500. Divided by 0.26, what value do we get? Get 9,615. Yes. Any questions, colleagues? I hope this is becoming our favorite course. Okay. Hope once residential starts, say, no, my favorite course is financial management. Okay, we go to the second part of the equation. It says, find the future value of an annuity where 2,500 is paid at the beginning of each year for 3 years at 27% per year. So now this annuity is paid at the beginning, so it's an annuity due. Okay, so this is the formula for annuity due. So basically, the only difference is it's like just the same formula, but we've put 1 plus R at the end here. Okay. If you look at the formula, they are the same, but for the annuity due, we've put 1 plus R at the end. So we already calculated the first part of this formula. Okay. The first part of the formula, this one which I'm highlighting, is it not highlighting? Yes, the first part of this formula here, we already did the tabulation and we got 9,615. So all we just need to do is multiply 9,615 times 1.26, since the rate is 0.26. Okay, so we're going to say 9,615 multiplied by 1 plus 0.26. Okay, so 9,615 multiplied by 1.26, you get 12,115.5. Oh, well, it's 0.27. Oh, okay, okay. Yeah, we have to do the tabulation again. So in the question, it said the rate is 20, 0.27. So I have to do this tabulation again. I was using 0.26, which wasn't the correct rate for the question. Okay, so A is still 2,500, open brackets, 1 plus 0.27 to the power 3, since it's after 3 years, subtract minus 1, close brackets, divided by 0.27, and all of this multiplied by 1 plus 0.27. So we'll do the tabulation. Remember, paid mass, you start with the parentheses or the brackets, then exponents. Okay, division and multiplication can be interchanged. Same with addition and subtraction. These, if you want, you can multiply first and divide later, or divide and multiply later, you still get the same answer. But you always start with the parentheses and exponent. So this 1.27 to the power 3 so 1.27 to the power 3 is 2.04. 2.0. So I'm just going to do the whole tabulation, so I just get a block figure. So this 1.27 to the power 3, I've got 2.048. 2.048, when you subtract it from 1, okay, well, on this part here, 2.048, when you subtract from 1, you get 1.048. Then, after you get the 1.048 multiplied by 2,500, you get 2,620. 2,620.9, and you divide this by 0.27. And whatever value you get, you multiply it by 1.27. So 2,620.9 divided by 0.27, we get 9,707. 9,707 multiplied by 1.27, you get 12,327. 0.9. Yes. So that's how you find the future values of an ordinary annuity, which is an annuity that is paid at the end of the month, year, and then annuity which is paid at the beginning of the month or the year.